watching Local Edition. My name is Brad Pomerantz. Thank you so much for joining us. Our guest is David Oglesby. David is a professor at the University of California in Riverside. He teaches geophysics, which is the study of earthquakes. Very simply, what's an earthquake?
An earthquake is when two big blocks of rock in the crust, near the surface of the earth or down deep, slide past each other rather rapidly. And so when those two blocks of rock, which can be very, very large, can be hundreds, even thousands of miles long, slide past each other, they push on the rocks next to them, and those rocks push on the rocks next to them, and so the push gets transmitted through the earth. And this push is the shaking that you feel in an earthquake.
And here we are in California. We are on the western side of California, and as a result, we are on one plate.
That is correct.
And the rest of the country is on another plate.
That is correct. We are sitting here in our studios here in Riverside on the Pacific Plate, as is downtown Los Angeles. We're all on the Pacific Plate, meaning that we're attached. We're on a big block of rock that's attached to the block of rock that is underlying the entire Pacific Ocean, Hawaii, places like that. Almost the entire rest of the country, including the Midwest, the East Coast, and in fact places like Joshua Tree, anything on the northern and eastern side of the San Andreas Fault is on the North American plate, a different tectonic plate.
And that's why we have earthquakes in this region, because they butt up against each other.
Correct. You have two plates that are right next to each other, and they are sliding past each other horizontally. So
you were kind enough to bring some animation. I want to show it right now, and I'd like you to tell me what we're seeing. This is the animation focusing on California.
Yes, so what we're seeing right here is a scenario earthquake, meaning this is a computer simulation of a possible earthquake that might happen in Southern California at some point in the future.
And it's a 7-point...
This is meant to simulate a 7.8 magnitude earthquake.
And tell us what we're seeing.
So what you're seeing here are an earthquake nucleating, meaning that the earthquake starts essentially as a tear in the earth. And in this scenario, it's starting down near the Salton Sea. And this tear in the earth is propagating its way northward on the San Andreas Fault, heading toward Los Angeles. And as this tear is propagating through the earth, what you're seeing is a bunch of colors radiating off of it. And those colors correspond to the strength of ground shaking that would be experienced at that place on the map.
Let's go to the next animation, and that is what would happen once that earthquake that you discussed hits the downtown Los Angeles region.
Yes, and so this is showing on the left-hand side of this animation. What you see is another view of that map that you saw before, but on the right-hand side, the bigger part of the screen, what you see is sort of a bird's-eye view of downtown Los Angeles looking to basically to the east. And so you can see the San Andreas Fault in the distance as it cuts through the Banning Pass over there. And at some point later on, what you're going to see is the earthquake, the tear in the earth, running down the San Andreas Fault, sending seismic waves toward downtown Los Angeles. And the important thing you're going to see is that these colors are going to sweep over downtown Los Angeles, representing the strength of ground shaking that's going to hit downtown Los Angeles. And what you may notice is that the colors are very, very bright, and the shaking is very, very strong in downtown Los Angeles, more so than in the mountains, because downtown Los Angeles is built on top of a big basin, essentially a bathtub of bedrock filled in with very soft soil, and it shakes like a bowl of jello in an earthquake. Now, the shaking that you're seeing is much exaggerated. It's not really going to shake that much. It's multiplied by some very, very large factor to make it obvious to the eye. But in fact, the shaking would be quite severe in an earthquake of this type in downtown Los Angeles.
I also want to put up a still. And this still demonstrates the probability of ground shaking throughout California. Explain it to us.
So what you're seeing here is a map of the state of California, and the colors correspond to a scientific consensus on what is the likelihood of very strong ground motion, very damaging ground motion over the next number of years, I believe 30 years. Mm-hmm. And as you can see, there are the areas that are dark red and almost brown.
And they are?
Those are the areas that are most dangerous, and those typically line up with the big active earthquake faults in Southern California, such as the San Andreas Fault.
It is quite remarkable that in our beautiful state of California, we really are subject to some violence that the earth can wreak on us, but yet it's going to be okay.
Well, we can
talk
prepare
about
for
it.
earthquakes.
We'll talk about it. Okay, for Local Edition, I'm Brad Pomerantz. Back to CNN HLN.